Letter I reads a solution of diamine silver 1 chloride is treated with dilute nitric acid. And what is the driving force for our reaction? Now this might be the most unfamiliar pattern dealing with a complex ion. So let me give a little background to letter I. First, when I read a solution of diamine, amine is the NH3 group as a complex ion. It's telling us diamine silver 1. So I begin by writing silver, and I know that it's a +1 charge. The word diamine is telling us that there's two groups of the amine ion. Now let me repeat that. When I hear the amine, amine, or ammine as it's spelled here, I think of the ammonia ion that carries a charge. Now I know that it will be a net +1 overall, as the Roman numeral told us in its name. Diamine silver 1 chloride would be written as Cl negative. It is then treated with nitric acid, HNO3. HNO3. Now, the driving force is simply a precipitation. When we precipitate out the silver, what it will hook to is the chloride ion. AgCl is the driving force. So we're precipitating out from this complex ion the silver and letting it hook to the chloride. The ammonia hooks to the hydrogen ion from the strong acid, giving us ammonium, NH4, and the nitrate, NO3. Again, I understand this is probably very foreign to us. I can give a page reference for complex ions. Page 748 in our text gives you a little background information on complex ions. Now we're still not finished, knowing that we've got some aqueous reaction occurring here. We're going to have to eliminate some spectators. Complex ion will be broken apart. We will have Ag parenthesis NH3 taken twice as a positive ion. You will often see a complex ion such as this in a bracket. Chloride is Cl negative. The strong acid HNO3, nitric acid, needs to dissociate. Strong acids 100% break apart. The driving force, we said, was the formation of this precipitate, leave together. Ammonium nitrate is a soluble salt, so we break it apart. Looking at eliminating any spectators, all I see here, the nitrate will disappear, and that might be it. Now, ammonium, nope, I'll need to double the ammonium, knowing that was two groups here. And what also I'll need to double to finish balancing is that nitric acid. That needed a 2 as well. So to finish, the nitrates canceled, leaving me two groups of ammonium +1. The silver chloride left as the precipitate, the driving force. 2 hydrogen ions, 1 chloride, and that complex silver diamine carrying a +1 charge. Again, a complex ion, something we're unfamiliar with. But generally speaking, here's the rule. If I had to write a complex ion, the original metal that we're familiar with, such as silver, in its +1 charge remains constant. And the general rule is if I'm adding a negative ion to create a complex ion, the number of ligands, which is just a fancy word for saying the number that I'll attach to it, is usually twice that of the charge. Since silver is a +1 charge, I knew that 2 groups of ammonia would attach to it. So just a general rule to help us with complex ions.